Perfect. Yeah. Welcome to the Haxe event here. So my talk is called From Nothing to Type Class, and I want to dive into the world of type classes and also called traits in some languages. And it's a little bit a side project that developed over the time, and it allows to use type classes with Haxe, but it's not, yeah, I can move to the next slide. It's not working with the current compiler, also not the development mode, etc. It's my own branch where this is actually working at the moment. There are still some issues, but most of the stuff is working. And yeah, it's more or less a proof of concept. And please, if you don't get anything in this talk, let me know and ask questions. So what is this all about? It's type class is a concept, and it's coming from Haskell actually, and it's also called traits in Rust. And there is also, that's quite interesting, I didn't know about that too, there is a thing called concepts, and it's a planned feature for C++, and it gets, when I understood it correctly, into the next standard, in the next C++ standard. It's I guess it's a little bit, it's equal to the traits in Rust. So if you know them, then you maybe know how this will work. So first question to all of you: who knows what a type class is or a trait? Not yeah, okay. Then there is also type classes in Scala. Maybe you know traits in Scala. Does anyone know traits in Scala?
That's interfaces, right?
Yeah, they are not type classes. They are just called traits, but they are not the same as Rust traits. Rust traits are much more similar to type classes in Haskell, for example. And then there's also PureScript, which has them, which makes sense because it's actually more or less Haskell for the browser, and it compiles to JavaScript. So what's the motivation for all of this stuff? The main idea of type classes is the separation of data and interface. So as in this example, you have a person type, and you have a name and an age, and then you have the interface, and you define the interface separate from the data, which means yeah, that's actually the idea. And the third thing here is the actual implementation of that interface for the given data type person in this case. Is that understandable? And actually this interface, or I call it type class, called equal, is to explain it, it's for structural equality. It's not for physical equality, it's for structural equality. Something that is, for example, if you have a deep nested data structure, it's quite difficult to get right in Haxe unless you use macros, or you use dynamic stuff. But type classes allow you to solve stuff like this in a composable manner, but we come back to this later. So what's this more or less the same concept in object-oriented programming? It's something like this. It's an equal class, but in contrast to the type class, you have only one type parameter. Yeah, the name A2 is not perfect, I guess, but call it X. And then you implement that interface, and that's important, at the same time where you define your data structure. So in this case, it's the person, the class person implements this interface. So that's a major difference between object-oriented programming and traits. It's you separate for traits. You don't have to implement the interface at the same time, where like this in this case, this is totally unrelated to this, because this can appear somewhere else in your code.
You kind of have to point with a mouse because people can't see your hands.
Ah, okay. That's
Sorry.
That's a nice note. Thanks. So, just because it may be a little bit confusing, all this interface type class. Why is it called type class? Because actually the same thing is called class in Haskell. This is, this here will be the only Haskell code that is in this presentation. So just to let you know that this is actually where the name type class comes from, and it's actually has much more in common with an interface in Haxe. So now the nice question: how to use this stuff? So you can actually use it like this. You have some kind of static utility like this equal API, and you have a public static function which is called the same as actually the function of that you defined in your type class, and you can use it like this. So, and if you actually want to really use it, you can call it like those guys right down here, the equal these chords here. Is this understandable from?
Like a comparator, basically.
Actually, yes. It's more or less like this. So now the ugly part of this is that you have to pass this trait explicitly every time, and that's actually not what we want. So,
cumbersome. Rather cumbersome.
Rather cumbersome, absolutely. And it gets worse if the trait is more complex. Because when the trait has dependencies itself, this equal person guy can be quite huge and can be can span multiple lines actually. So what we actually want is to get something like this. So you have maybe this is good to say. I use the capital variable names for the type classes to make it clear that this is a type class, to separate them from the normal function parameters. It's just a convention. It's not that you have to use this. So, and actually, if you have something like an implicit, that would mean in the two calls right down here, these are the new person stuff is actually automatically inserted by the compiler. So this is actually where we want what we want to achieve. Then type classes are very modular. That's actually the same point that I already made, but maybe this is more clear in this example, because you have to implement all the interfaces in object-oriented programming at the same time where you define your data type. So this is more or less the same in combination with type classes. You define first your data type, and then you have the different traits that you want to implement, type classes, this is very modular. You can implement them piece by piece. You can also, if you're the author of the same or of a different library, or you are a user of the code, you can still retroactively create type class instances, even if the data type already is declared. So in other words, you can also create implementations for type classes for standard library types, for integer, etc. There is no overhead there at this point. Yeah, that's actually the point that I made here. You can actually create a type class called compare, and you can create an implementation for a string, and this would more or less look like this. That's also a nice side effect of the way type classes works, is you don't have a problem to create or implement a type class for abstract data type. So because sometimes you see questions like, yeah, how can I implement an interface for an abstract? Of course, that's normally, there's no way to do this. With type classes, this is not really a problem because they work differently. Any questions up to this point?
Well, this example could actually do something rather than just boxing it. It would be more fun.
Yeah, I know.
Well, so far so good.
Cool. Some things unclear.
Well, are you going to talk about how this implicit thing works?
A little bit.
Later?
Yeah.
Alright.
Okay. This is another very important point, is that type classes compose. So as you can see in this example, you have a simple toString trait or type class, and you just have a data structure, and you have a conversion function to convert a data structure to a string. So then you have a simple implementation for a Boolean, not very fancy. What is important is the implementation for the array, because for the array you actually have a dependency. The dependency is actually how you create a string out of the t, the type parameter. And so a type class can have a dependency. So and this actually means that stuff like this is going to work. Okay, in this is quite cumbersome, but you may see what the composition of the type classes in this example, because with one implementation for the array, you already implemented the type class for an array of an array of an array of an array, whatever. So, and this is how type classes compose, and that's a very nice effect. Exactly, and this is the same example if they were injected implicitly in this example. Another aspect is you can implement actually a type class for a combination of types. So it's not, you are, at least with this implementation, you are not limited to implement a type class for one type. So in this case, it's about the abstraction of a plus operation, and you have two data types, A and B, and you have a resulting data type that is C, and actually you have the implementation. You can think about it a little bit like overloading. You implement this for meter and miles, the plus operation, and the resulting type is a meter. So in the same way, you could define this stuff for meter and centimeters, for example, or whatever you want at this point. So you can, for every combination of types, you can define a type class actually. So you're not restricted to one type parameter. Any questions for this?
I wonder what kind of error messages you get when you don't have implementation class, because what puts me off of Haskell is it looks really nice when everything works. That makes a lot of sense. But once something doesn't work, you get these kind of errors that make you go, okay, what does that even mean? And I wonder what kind of error you'd get in a case like this, where you forget to have an implementation or something.
It's
What
more.
happens?
It's more or less if you use if you call a function and there is an expected implicit
Yes.
of such a type, then it will it should report a warning, something like an error, something like plus 4 miles meter is missing,
Okay.
or I cannot find an implementation for this type class or this trait.
Okay.
Not sure what the
Hmm?
Better than
Yeah.
Holzer.
Yeah, we have the same problem with map in some cases. When you try to index on the map, it tries to find a type and field lets you do that. And it's really hard to come up with an error message that makes sense to people, because you have to say something like, could not find operation for types this and that, and people don't understand this.
I know what you mean.
Yeah.
The point in the map thing is because it also is a quite special thing in
That's
the
true.
Haxe standard
Yes.
library, and actually I don't know of anyone who uses this stuff
I hope
for
not.
something else than in the standard library.
I hope not. No.
So you're totally not used to stuff like
Yeah.
that. If it's a major
Yeah.
feature and you're more or less
Yeah.
used to this, I guess it's different.
Yeah. Okay.
Or I could imagine that
Yeah,
it's
fair
different.
enough.
Or
I wonder how well this works with subtyping. Like if it was not meter but some interface, or even an abstract that has to and from, and is this compatibility?
no,
in-
there is
there is
no
something.
subtyping at all at this point, and this is quite important actually. The type class is always resolved on the call side, and actually exactly on the parameters, on the types that are available on the call side. So if you have, for example, something like abstract miles with a toInt, and then you will not get the algorithm will not look for a type class for the type int. It will just look exactly for this type.
I can see some confusion, like if you have an implementation of type class for some interface, and then you have an implementation of that interface, and then an implementation of type class for the implementation for the class, but it won't be used if that value of that class is used as an interface. Does
Yeah,
that
I know
make sense?
what you mean. The point is inheritance for the data types and type classes don't play very
Yeah,
well at
but
this
I
point.
mean, in Scala
And,
it works somehow, I guess, or
No,
not?
I don't think so.
Not really.
It's
Okay.
this. I'm pretty sure that's the same there.
But I get some errors.
Because I guess if you would allow this, it would get ridiculously difficult
Yes.
You get
I can-
different
and
possible paths.
confusing and
Yeah.
confusing.
I mean, yeah, if it gives errors when you try to define a type class for a subclass, because I mean that what would one expect, I guess.
I'm pretty sure that you could hack something together, but the question is if you really want to go that way.
As it was said before, if it's possible, then someone will do it. But okay.
So at this point, this is not possible, and I don't plan to implement this because I don't think it's a good idea, actually. Okay, next point. Yeah, the next slides are something that we can try this. It's about higher kind of types. I don't know. Maybe but it's not so important. If you don't get it at this point, then it's not that well. The examples maybe will clear things up. So, what is this all about? Type classes work very well with higher kind of types, also known as type constructors. What is this type constructor? So, first of all, what are regular or concrete types? So int or string maybe, these are concrete types. Another example is array for int. It's a concrete type. If you remove the int from the array, you have only array, and this is a type constructor because it requires another type to become a concrete type. So in this case, array and t becomes an array of t, and then it's concrete. Is this clear?
But T isn't concrete, is it?
It is concrete, yes. That's fine.
How is T
It's-
concrete?
It's an arbitrary concrete T.
Okay,
Yes.
everything is like
It's
a
a
class.
variable.
Yeah.
So it could
yes.
be int or something. Okay.
Yeah.
Okay.
Name a number X.
So, this is a good analogy. You can think about array as a function for types. So, array is a function that expects another type to become a concrete type in this case. So, array plus t becomes array t. When you have something like this, then you can define something like this iterate function here. So, the special thing here is that f at this point, this is not working in the development branch. This is just working in my branch. It's a type parameter which has again a parameter. So this is f of int. You can define in this branch something like this. So examples would be array, for example, array of int or option of int. It's quite good to understand when you think about all this container stuff. So you have lists, you have maybe hashes or stack or whatever, and they all have the same element type. But it's a little bit misleading because actually it's about this function on types. This is the important part at this point. So this is a little bit complicated because actually we would like to just use array without parameters, but the compiler doesn't let us. So we need to make the compiler happy at this point, and this is where we introduce a new special type, which is not a type, it's syntax, and this underscore in this array int example, this just means there is no type at this point. It's actually exactly the same as the array without the parameter. Yeah, as you can see here, this analogy for functions with the binding is more or less a little bit maybe helpful. If you bind an underscore on a function, it's actually for a one parameter function, it's actually the same. And if you have this, actually, then you can implement something like this stuff right down here. You can have a type class called iter with an iterate method, and yeah, I don't have an implementation here for the array, so just it's quite easy. Yes, you can imagine, right? This is oh, the syntax is a little bit ugly here. Okay, if you have this is just an analogy. If you have you can also have type constructors that require more than one type parameter. For example, it's an either type. It requires two type parameters, left L and R, and so it's actually a function with 2 parameters, which becomes then a concrete type. A nice thing is that you can also have partial application on those types if you want. So if you just provide the first type of an either, like in the last example here, you have the L, and then it becomes a type constructor for one type. The example will maybe makes this more clear. So again, this is actually at this point with real implementations. You can have this iter type class, and then you have an implementation for an array. The same for the string map, which is exactly more or less the same from the code, but from the typing, of course, it's different. And it's as you can see, there is no abstraction in the implementation, so it's really based on the raw types. Another implementation for option, for example, where you just iterate over the one element that's inside of an option. And same could be done for an either type, like in this example, and it would work exactly the same. Any questions up to this point? Is that clear? Yeah. Okay, now we're coming to the implicit stuff and how does this implicit resolution works. I can just say in the beginning that this is still not, this may change, because I'm not 100% happy with all the stuff that's currently how it works, but we will see how this works at the moment. Okay, so as you can see in this example, we have the type class at the end, and if you apply, you have two arguments, it's the A and the E, and if you actually apply the first parameter to the toString function, the new type becomes toString array of bool. So what we actually want to have is an expression that actually matches this type, or we want to have the type class, the expression which represents the type class inserted at this position. So yeah, maybe we can use macros for this, and actually yes, we can, but actually with something that is not yet in the compiler. It is something which is called from nothing, and the idea is actually that you have a parameter that is optional, like this E. This E would normally become null, but if you have worked with this special posinfos class in the compiler, you may know that there are also optional things that you don't have to provide, and it just works. And the idea is actually exactly the same. And you have an abstract which has a function called from nothing, which then can create whatever expression you want. So in this case, we use at this point the getExpected type, where we can actually get the expected type in the current context and try to find the type class for this. So the instance. So what happens inside of this function, or in the implicit resolution, how I call it? We are first looking for candidates at the position where this resolution or this algorithm should look for, and if it first looks and we just want to look for special kind of variables that are marked as implicit. So you have to actually mark them as implicit to be available for the algorithm actually. This is what you can do with the metadata, with the implicit metadata. Or you can also mark those stuff with the type. So if you wrap an implicit around the type, then it becomes automatically available for the resolution mechanism. And any questions to this? Maybe.
What's the scope of from nothing? Is it only meant for function arguments, or would it also work in other places? Like if I declare a local variable and say it's implicit, but I don't provide a initialization value, would that also create something?
Didn't thought about that. You mean for something like a static variable?
Not a static, a normal local.
Without initialization. I don't. It doesn't work yet.
Should it work?
Not
because
sure.
I feel like from
Not
nothing.
sure.
I think we
Otherwise,
should find a better name.
you just call a function that returns the implicit argument, and you initialize with that.
Yeah, I mean, my concern is that this from nothing has a name which suggests that this would work. But if you only want to use it as for call arguments, then maybe we need a different name for this. And I'm not sure what I'd call it, but I think that
I don't care too much about the name of this
but people
thing.
generally do. I don't care either, but there are many people who are like, this should be called differently.
From nothing for argument.
Yeah, that's perfect. Yeah,
Maybe it's too short. Still too short.
I'm not opposed to adding this from nothing or whatever we'd call it. I don't see a technical reason against it. So if we find a better name, maybe
it works quite well in my. But what's important? That's actually also something that I implemented in my branch is that you, if you bind on a function, then
on a call. You mean?
Yeah, on a call exactly. On a call, then it's important that this will run this macro at this position. So it should never become null without the macro run.
Oh, you mean it uses the null default value?
Yes.
Yeah, that should.
Yes.
Happen.
Exactly.
Why would that happen?
But the problem is how it's working in bind. If you do a bind, optional parameters become
the null padding. Yeah. I see what you mean. So instead of null padding, we would check: do we have this implicit, and use that instead of null.
That's actually what I do in my branch because that's quite important to do this.
Yeah, send a pull request.
Yeah, will do.
Everyone, this is how you get stuff added to the compiler.
Yeah.
Okay. Any other questions?
Not looking.
Just talk to Simon and then get it pre-approved.
Have I lost someone?
No. I'm not
That's
sure
good.
how to
That's good.
construct the question actually, but I wonder how does this work in a generic function that expects a type class?
Yeah, that's a little bit tricky, I have to say. In general, it works, but there are some problems that needs to be solved to make it as fast as possible, to say it this way. But I have some examples that actually show the problem and also how you can solve this in simple cases, but it's not beautiful.
So one question I have is, do you have to declare all of these implicit variables for all of the toString, for every type you want to convert?
For
It's a
every
choice.
type you want to convert.
Like you had an array of arrays of bool. Do you need to specify an implicit one for this?
No, this is because if you what you have to provide is for array and for a bool. and then it automatically works for nested arrays. So an array of array of array of array works.
So this from nothing implementation actually not only search for the value, the instance of the type class, but also for the constructor function.
Yes, for the dependencies. So the dependencies are also resolved.
They are also implicit.
Yeah, that's.
Yes, in that case, yes.
But you have to bring something into context, right? So
Not anymore.
not anymore, okay.
No.
So how does it know where to look? How does the resolution?
Yeah, that's
Oh,
coming.
that's coming up.
That's
okay.
coming. That's coming. Okay.
Ah.
So the resolution scopes. Well, maybe this will change. I'm not really sure. I started with a version where you really go into every scope, and then you're looking for possible implicit candidates to insert. But I'm actually not 100% sure if that's the best way to go. What's quite important is the local. The local scope is very important, and actually the last two scopes, the global scopes. The question is if you want to make the type classes flexible, so which means more or less the Scala way, where you can have when you bring a variable into the local scope, then it automatically picks this up, and you can have more than one implicit for the same type. That's actually possible in that case. It's also possible at the moment in this implementation, but I will show you how this works at the moment. Because the algorithm is first looking in the local scope. When it finds an implicit that matches the type, that's fine. It doesn't look any further. So if it finds, and then again it goes to all the other scopes. And how this works for the local scope is quite simple. You just have to mark them as implicit. You have to mark the type as implicit. It would be nicer to have some metadata for this, but this doesn't work with local expressions. At least it's not possible to extract this info from the macro side.
Oh yeah, it's fun.
You have to run a build macro before it does that.
Yeah, that would be possible, but I wanted to
Compile
avoid build macros for this stuff. So this is actually how it works. The same is for function parameters. So the nice thing is when you actually define a function with an implicit inside of the function parameters, it becomes automatically available inside of the function for another call.
What if you pass two of them?
Then if you have, I guess I have an example later, where you have two implicits. So let's say you have equal int 1 and equal int 2, exactly the same type. You will get an error,
Okay.
ambiguity error, something like that. The word that I always spell wrong. Okay, then you have the member scope. This is the second scope. This is actually only important for, of course, member variables, because in the static context there is no member scope available. But if you have a member function, then it will look into the member variables. And here it will just look for this special metadata thing called add implicit, and if it finds something that matches the type, then it picks it up and generates an expression
Why
for
do you
this.
need implicit type declaration and implicit metadata here? What is the
The
difference?
metadata is preferable, but it doesn't
Yes.
always work, which is why the type is there. In the places where the metadata is just stripped by the compiler.
Actually, I would
And the expressions metadata is just thrown away by the
Okay.
time it's typed.
We could change that. We do for some metadata. We keep some of them.
Yeah.
So
Yeah, there's something. That's one way. There is some other problem. Is I don't really like the overhead of the implicit type inside of this inside of the function parameter. I would prefer to have something like an implicit metadata, but this will not work very well with from nothing stuff because the value is actually always an implicit. Of course, you can make it as nice as possible, you can forward all the stuff and so on, but it's still an implicit and not the actual type that you want at this position. So it works well at least, and I didn't run into any problems, but it's still something that's not really nice. Okay, static scope is actually the same. It's just a static variable with an implicit. And then there's also a module scope. I'm not sure if that's a good idea, but at the moment it's there. It looks for implicit public static variables in other types inside of the same module.
That sounds bad.
Without having to import.
Yeah,
Without having to import.
that sounds bad.
Yeah, that's why I'm not sure if it's a good
Yeah.
idea.
I just follow normal resolution order. That should be fine.
Yeah.
I think.
Okay, then there is the using import scope, which is at the moment not one scope, but this is very bad. Actually, I want to make it just one scope. So everything that's inside of the using import stuff is at the same level, which means if you have more than one in that scope, then you get an error. At the moment, it's like this. If it's via using, then it will take that one, and if there's another implicit inside the import scope, then you won't get an error because it will pick up the one from the using, which is not nice at the moment.
But
I'm not happy with that.
Why do you care about the using at all? Because all usings also declare an import. So you can just ignore the using.
Really? I didn't know that.
All usings also do import.
Yes?
Yeah.
Interesting. Okay.
Yeah.
Then
So
I
you can just ignore them, I think.
Okay. Yeah. The question is if you want to give explicit imports another precedence at this point. Not sure if that's a good idea, but actually I started with this stuff, and later I added the global stuff, and the global stuff is actually that what you most of the time use, and it's also something that has the best performance because it's global and you don't need to evaluate the context on the call side for the global stuff because you just need to do it once, and that's very good.
Yeah, but with your resolution order, you still check all the local stuff first, right?
Right.
So
Right.
you didn't really win anything because the fast stuff is at the end.
Yeah, actually, it's quite fast at the moment.
Okay, yeah.
I'm pretty sure it gets better, of course. But this is something that's well, the way how I look for this stuff is quite optimized.
Okay.
I do a lot of caching at this point, and yeah, at the moment it's quite fast. But I'm not sure how if it scales very good. If it scales okay.
Mm-hmm.
So, but not sure if it's in a really huge application, if it's a problem or not.
But do you really need this local and member and static handling? Do you really need that?
The
level of
local
control?
stuff is important. The local stuff is important because if you have an implicit for a type parameter t, for example,
Oh right.
then you need this for resolution. But I have an example
Yeah.
for this case
Yeah,
also.
okay.
How much time have I actually?
As much as you want.
Yeah.
Okay.
Keep going.
This is maybe the most common context, and I call this at the moment the type class and the implementation type context. It's actually when you define the instance in the same file as the type class, then it's in this scope actually. So if you have a module called equal, like in this example, and the equal for int is in the same module, then this gets picked up in the global scope. So there's actually, if it's in there, then it's actually no need to have something in your local context to make it work.
Yeah, but that defeats the purpose, right? Because you have now the interface and the implementation together, which is what you're trying to separate with type classes. So that's a bit of an anti.
Yeah, actually it's not that bad at this point, because there are ways to get around this. But often the case is if you create a type class like this, then you want to put some default implementations for this.
Okay.
For example, if you have because most of the times you have the one way or the other way. So you have the case where you define your new data type, and at the same point you often want to implement those type classes. Or you have the other way around. You have already a data type and you want to create you already have the type class,
Yeah.
and you want to create your data type and with all the implementations.
Okay.
So these are two very common use cases, I would say, at least for a lot of stuff. But there are ways to add to add more of them. This is the other case. You have your data type foo in this example, and in the same file you implement the equal for int, and this will get picked up automatically by the compiler of the macro.
EQ of foo.
Right, that should be equal of foo. I'm pretty sure it's not the only error in the slide.
I think if it would be possible to just write implicit on the class, and it would automatically make an instance and construct.
There is stuff like this. There is stuff like this, but I wanted to make it clear what really happens at this point. And if I would put all this magic in there, then nobody would understand why this will work.
Good point.
Yeah, this is the other way. This is really by convention. The point is the following. The compiler actually only loads those classes that are referenced somewhere. So if it's somewhere in your package structure and it's never mentioned anywhere, then this will not be picked up. So one way to add another, let's say you don't have the control over the creation of the type class or over the data type. So it's a type of library A, and it's a data type of library B, and you have no way to change the modules directly, but you want to have it globally. You want to have it globally available, a type class. Then you can put it in a special package, and which is based on the name of the class, lowercase, and there is another package instances, and there you can put all those stuff.
What's the name of the file?
It doesn't matter. The macro will look for them. So actually, all of
can
them.
be many. Okay.
Yeah. It's from performance point of view, it's not a big deal because it will only be done once. And if you have, for example, if you have two libraries that have in the same package provide an implementation for the same type class, you will get an error. So this will not work.
But isn't this case covered by import HX? So you would just add your data type and your type class in your import HX, and then you always have them?
Yeah, but how do I know in the macro itself where should I look for this stuff? I don't know
the
where.
local module still should have them, because import HX.
You could just globally import it for a whole class path, basically.
It basically
but the global stuff is faster.
Yeah, but basically it becomes part of the local import list. You can just pretend that the import HX files on top
You
of
can do this, but as Jura said, it's a lot faster if I can have it globally and only resolved once and available and cached, etc. When I have to do this on every module, and not only every module, with actually on every call.
Mhm.
Of course, you can use caching, etc. to improve this, but it's still. I wanted to have another possibility to make this global because it's faster,
Okay.
and you don't have to deal with this import stuff. So it just works if you define it in this folder actually.
Yeah. I'm just a bit concerned because it's kind of starting to get a bit magical at this point. You start with
It's not
conventions
set in stone, so
yeah,
it was
that's
just
what- that's
it
what
was
I'm
just
asking.
the best idea that I came up
Yeah.
at that point, and
Make implicit a keyword and then call it implicit dot implicit.
that will be possible. But the problem is there are more than one.
Yeah, sure.
Yeah.
What's happening in this code? You are calling EQ option without parameters, but the
Yeah,
constructor
it's just a sketch, I think.
the constructor expects a parameter. Is it a
That's a mistake.
Okay.
The equal option should have this equal t should be passed to the constructor. Yeah, then there is something else which is of course a little bit difficult. You have a hierarchy of type classes which is also supported. This is actually, say, if you have something a compare type, or in this case I called it ord, which is nothing else than you have a compare function for two types, and you also have, when you have a compare, you also have an equal type class. So you have some kind of type class composition or inheritance or whatever you want to call it, which just means that a type class can also be automatically a type of support another trait. So something what you want to do is to have, for example, 5 different type classes, and you want to put them together because it makes sense, for example, and then you don't have 5 implicit parameters, you only have 1 implicit parameter at that point. And also you have access to the implementations of those type classes inside of the other type classes. So inside of the ord implementation I have access to the equal implementation. Does that make sense?
Should it be public though? I mean the inside, because it should be like an implementation. I mean, if
No, it's part of the contract, I think.
yeah,
If
but
you
why?
look at the
Yeah, it's part of the contract. That's part of the contract actually. That's
But
quite
you say
important.
something orderable has a comparator and equality, as far as I understand.
I mean so the user of ord type class should only use compare function, and they should not access EQ, I guess.
Ah,
right?
no, they can actually.
Should they?
That's fine.
I mean, okay, but can it be private if I have a type class that
We could-
requires something
But I
else?
think it's not even used in their equality. It's just sometimes equality is cheaper than actually comparison. Yeah.
Yeah, and sometimes you want to have a, well, let's say you have a function, and you want to have you want to say that the type that you pass in is comparable, for example, and then you can inside of this function you can call another function that expects an equality constraint.
Okay.
That's actually possible this way.
Yeah, but if I would not need that, could I make this EQ private? I guess I could, right?
Then you
But
wouldn't
it's not
need
even-
then you wouldn't need
it's
that
not
at
even
all.
used.
then you
Otherwise,
wouldn't need that at all.
The point of it being public is that it becomes part of the contract.
Right.
Ah,
It's
Kind of like inheritance.
okay, I see
Only
now.
through
Yeah.
composition.
think about it this way. Maybe you have an iterator type, and you have something like let's say a collection type, and you have some a fold method and maybe a length method or something like that. And you could define those two traits separately. You could say has length or can iterate in something, and then you combine them to a container type which supports both of these operations.
I remember from Haskell there was something like that equal type class was defined as some default implementation. So equality would be defined as not inequality, and inequality would be defined as not equality. And in order to implement it, you only had to implement one, and it would use the other. Do you have something like that too?
No, I don't have something like this, because actually you could add this stuff, but I
don't think it's useful. I just found it curious.
I think it's quite it's a different thing.
Yeah.
It's a different thing. So it's totally useful, of course, but it's not tied to type classes at all. Because, for example, in Java you can do this too now. And Scala traits, for example, are another example where you can have this, and it has nothing to do with type classes at all. These default implementations.
Okay.
You
Yeah,
could
I
have
see
it,
your
of course.
idea. It's kind of like an abstract in Java sense thing. So you have to implement the part that is enough to make it concrete. So it's no longer abstract. Okay, yeah. Yeah, you're right. I guess that has nothing to do with type classes inherently. Okay.
But yeah, in combination with type classes, it totally makes sense, and for some cases. Okay. Yeah, actually, and what the last scope, the type class hierarchy scope, does is to convert the odd type, for example, this one, to an equal type, and then when you have only an odd type available, then you implicitly have the equal type also available. So it's actually just an implicit like everything, like every other, with a lower precedence at this point.
So it wouldn't cause ambiguity errors. Like if you have an odd and an equal both, it wouldn't cause any problems.
No,
okay.
Only if there are two in this scope. When you have two conversions defined in this last scope, then you will get an error.
Yeah, if you have two odds, you would get an error, but not if you have odd and equal. Right?
Yeah, the equal has priority. If you have an equal,
yeah, that's what I mean.
Yeah,
so
then the equal is picked up.
Okay.
Yeah, right, and the odd that's actually a fallback. So if we don't find an equal, then we use the equal from the odd.
Mm-hmm.
That's actually what it does. Okay, yeah, that's actually something we already talked about. It's about the dependency resolve, means how this works, the resolution stuff. And this is just an example. For this, you have an implicit, in this case, an equal implementation for an array of t, and the instance needs a dependency to the other, the equals for the t type parameter, and it's a little bit complicated because, for example, if you have a class called a class like this, then this gets available for the resolution mechanism for different types. This is actually it gets available for equal array without the angle brackets, but also the interface equal of array. So that's actually the point that I made in the second sentence here. It's this one is it's available as this type, and it's also available as this type. Does it make sense? Okay. So the point is, if you know that you actually want the first one, then in some cases actually it's just how the implicits work. It's for every interface and for every subtype. They are all registered for implicit resolution at that point. So actually, you can use this implicit stuff. That's something not quite important. Also for other stuff than type classes. So the implicit stuff works for other types too. So it don't have to be a type class. It could be just an int or something. Okay, yeah, the ambiguity, errors. If you have something like this, then you get an error. The errors are not perfect at the moment, and there's still improvement. I guess there is actually should be the error. The equal thing here should actually contain the arrow brackets, but the markdown stuff was yeah. There was a problem with the markdown rendering. So the actual type should be here. Okay. This stuff, maybe this is not so important at the moment. Yeah, actually when we collect all the candidates, I make base a lot of caching and laziness to do only as much as possible, and there are still some stuff. Of course, if you move that to OCaml, it should be faster. But the bottleneck still, in a lot of cases, is typing. Typing is really so I avoid typing as much as possible. So I have, for example, for all this implicit stuff, I have some maps where you have keys, and I first filter on those keys, and only if there is an candidate behind those keys, then I actually really try to unify the stuff to make it as fast as possible. Yeah, this is just an example that in this case the last slides are not that great actually because I had more time and I didn't know where to put all those stuff. Yeah, this is what you mentioned actually. The implicit instance sugar is you can implement that interface implicit instance, and it automatically generates the stuff that is missing in the example below. Yeah, this is actually what this does.
I can't tell what this does, sorry.
Okay. The implicit instance in the example below.
Yeah.
This is the same example, once with a special class implicit instance.
Yeah, it looks like it's the wrong way around, right?
Yeah, right.
Okay.
Right. Yeah.
Now it makes a whole lot
Yes.
of sense.
And the translates is missing an S also. So it should be the other way around.
Okay.
The example below should generate the one above.
Okay, that makes more sense.
Okay. Yeah, actually, and in combination with higher kind of types, you get all those stuff like functors, monads, etc., transformers, all those Haskell stuff. It's actually working, but I didn't want to go into that area in this talk. Yeah, there's one limitation at the moment. That's a return type polymorphism, and this is a good example because you actually don't pass any parameter, and the implicit that should be inserted at this position is just it depends on the return type. So this is actually at the moment not possible. What you can do, you can do some workarounds. You can use a macro for this. Then you can. It's actually the examples that I added here. You can. There is a helper function implicitly. The name is not the greatest. It could change, and then can you? Yeah, that's important. Even
explicitly, though?
Yeah, you can pass them explicitly. Like in this case, the implicit is passed explicitly, right? But this is also something that you could use for some optimization stuff, to pass them explicitly. Yeah, you can. Yeah, it's nice markup here. Yeah, you can also use a macro, of course, and use get expected type and build the expression based on that. There is another way that I use sometimes is you have some kind of a type argument which is not a real type, and it's used to infer the type for the implicit, like in this example. Actually, in the example here, I use a string just because it's the shortest way to pass a type to a macro. And I dislike this null. Yeah, the check type syntax is ugly. I like the string more than that, actually, because it's shorter.
Ouch.
Yeah, in that case this will work. Yeah, limitation is it doesn't work in macros, of course. You cannot have type classes in macros because yeah, and there is also a limitation. It currently works on the dynamic targets. That's not a big deal. C++2 and I guess the last time I checked also hashlink, but Java and C# have still some problems with mainly the higher kinded stuff. Not really the type class stuff, but the higher kinded stuff. Oh, that's nice. This is not how it should look like.
You changed the font size.
Maybe it's because of that. Yeah, some links and some stuff that is working, but this is very work in progress, and I cannot guarantee at this point that anything of this stays as it is. The first thing is the compiler branch. It's the higher kind of types, forever final at this point. You can see there were some other branches before. And then there's the implicit stuff. This is in Scuds implicit. It uses the Scuds macro kit, which just has some functions for arrays and stuff like that. Nothing fancy. And there is the implicit instance stuff. There is actually more, but I didn't want to make this stuff public yet because it's not really usable at the moment, I would say. And yeah.
Do you have some project which is using this?
I have examples. I have not a project that uses this, but I have some examples. They're quite short, of course, and nothing. No real world applications that uses this. But I guess it would already work for a lot of stuff if you use it extensively. I have no idea how well this works performance-wise, but I already spent a lot of time to improve the performance of the resolution mainly, and it was a lot of work to get this fast. And yeah, I can take a look at the examples. Well, up. Yeah, these are some examples that I created in the last week, so they are not too great. I have also this generic stuff. So that's the example for Nadako actually. This is actually working when you have when you use this in combination with the generic things. Yeah, it just generates the right code. I can also open no. There's also try Haxe. Yeah, it's very slow. It's on my personal server, which is very slow. And so let's see if it works. This example. Yes, it works. This is nice. You can also take a look at the generated code. There is already some optimization done. Can you see this actually? Yeah. So what's interesting is here maybe the call here with
the main, can you show the source, the main function, just for comparison?
it's here just the mapping stuff. It's how you would expect it. When we put some inlining here, it gets better, of course. Here and also this guy. It's a little bit cumbersome to because you have to create the type class itself, and then most of the time you have also to create an well, I call them API class. It's just the static. Yeah, the static.
That actually applies.
Yeah, that you can use actually the API that you can use for yeah.
So it's static functions with this implicit arguments. Right?
Exactly. But I have also a type a macro that generates them out of a trait or out of a type class. It's not that difficult to get this working. I have also some derive stuff. If you know what this is actually it's auto generation of type classes for some common stuff. For example, equality is an example which is relatively easy to auto generate, so you can have macros to generate them. The output in this case is yeah, it's optimized. Is this the main? Yeah, it's optimized away.
No. Ah, there it is.
There it is.
910.
Yeah. It's not in every case perfect. This is really perfect. Let's say you can't get it better than this, but there are some cases where we have some problems, especially when you have type class hierarchies. What I really want to have is that you have static dispatch on these types, and you have very optimized code that is generated. That's actually what Rust does. So Rust creates a function for every combination of type parameters.
But I mean, if those type classes are resolved at compile time, and if the type class has a dependency, so then you insert this new type class instance and pass a dependency there. And if the constructor is inline, I think it could be well inlined.
Yeah, I don't put the new was just for so
I mean,
without optimization I just put the new in, but I have some optimizations that do create those instances once and then just
For
reuse
those without the dependencies. Right?
Yes, for those
I
without.
mean,
Also,
there is a
also with the
dependency.
dependencies, I use for the type combination.
Mm.
You can, let's say you have an equals for an array int. This combination of from equals array and int can be stored in a in a variable and can be reused.
But I'm just wondering, even if they are not stored, but the constructor of the type class implementation is also inlined, like public inline new, it could be also nicely inlined, right?
Yeah,
Because it's
theoretically,
complex.
if you go all this optimization from, if you have all these optimizations in place, and you could optimize all the way down, all the way up and down, then you could create really optimized code. But the problem is at this point that some stuff doesn't get optimized like that.
Because it's typed as an interface or something.
Yeah, for example, because it's typed like an
Okay.
interface, I have one example for this. Actually, it's some kind of a benchmark. All this generic stuff, and well, let's say take what do we want here? For example, if you take this one, plus constraint, not optional, then I put the type class actually yeah, if the let's take the plus constraint, that's better. This is a special type which I just created because I realized this doesn't work as it should. I have an implicit generic which this actually works. You can say it's an S, but you should resolve the plus T. And when you type this as S, but this is something that if the compiler would be smarter at that point, and it doesn't create, for example, if you have an equal interface and you have an equal of T, so the compiler will create perfect implementations for the interface equals int or equals string. But what it should create actually is not the equals int. It would be better to take the implementation class at that point, and if it would use the implementation class instead of this optimized interface type, then it would be a lot better. Yeah, there are some other examples. Something that you can do very well is stuff like serialization and so on. In this example, this is just JSON serialization. Also, I just created some basic stuff. So JSON data is just an object, a string, or an int. I didn't add the other cases, and then you can then you have a type class which is called toJSON. And then you have implementations, for example, for your person, which is this one here, with name and an age. And then you create the implementation and convert this to a JSON object. And if you have a JSON object, then it's easy to serialize this. So if you do it this way, then if you have an arbitrary data structure, as long as every of these types has an instance for toJSON, this just works. Yeah. I have more examples, but I guess that's it for the moment. Or do you want to see more?
This is heavy duty dog.
Yeah, no.
It's kind of like
That's why it was hard to prepare the presentation and to make it interesting and also understandable. And that's also the reason why I didn't dive into stuff like monad stuff and so on,
Next
which
time.
is interesting but
It's
not.
good to give people's brain a little bit of exercise every now and then, right?
That's true.
So if we would like add this by step into compile, then the first step would be to revive that from nothing. Yeah.
Yeah.
Right.
Well, the first thing is to look at this and see what's good, what's not good, what should be changed, etc. But it's the good thing is that it's already working, at least in my branch, and you can at least see the different use cases and the different stuff that you may need to support or decide to not support.
I mean, this from nothing thing, I think it's useful by itself as
Yeah.
well.
Yeah.
You can use
It
it
has
for
many
like
applications.
DI or something
Even
like
with
that.
prop drilling, probably.
Yeah.
Hmm.
I think you made a pull request at some point from nothing.
Yeah, I know,
was-
and
was-
actually at that point I made adjustments for this stuff, and I wanted to see first how the implementation is good and what's still missing in the implementation of the pull request. So at some point I have to update the pull request with some stuff that I added here. It's actually the binding stuff, the function binding, and where the from nothing macros should be called instead of not called and a null inserted. That's something that is inside of the branch and not in the pull request now.
Yeah, I think we should definitely add from nothing or something similar. I really see no reason not to add it. And beyond that, I don't know. We'll have to see, but I think that would be the first step, definitely. Because then you can already do a lot of the things you're doing right now. I wonder how much of the things you implement are in OCaml and how much is in macros.
Most of the stuff is in macros.
Oh, yeah, that's what I thought.
So the point is what I have inside of the compiler is higher kind of types.
Yeah,
The support, that's something that I cannot solve in macros,
yeah, of course.
at least not in a nice way. That's there, and there is also some adjustments that I added to the compiler because I ran into problems at some point. I had some unification problems with the expected type where I also did some optimization, so I added something to the macro API to optimize some cases.
Oh.
But actually, because I was playing around, I'm not sure which ones are still necessary and good. And you also have you have this round trip from the macro runtime to the OCaml compiler and so on. And this is a small overhead, and at some points it is I had some problems. Or
Did you try to rewrite your macros in OCaml like Alexander did for null safety, whatever, for routines?
it is possible, but I didn't want to do it because first I want to have the implementation
Makes sense,
right
yeah, of course.
before I want to translate it.
I mean, to get rid of round trips.
Yeah.
The like correct way.
And also I would like to add more unit tests. I mean, I have some unit tests now, and which is already quite good when I try to when I try to pull the development branch into my branch. So I'm actually always running all these tests at the moment to make sure that nothing broke my stuff, or I had to change that in the
round tripping
branch.
should be faster now too, because we use some lazy values, so we don't always encode everything eagerly.
Yeah.
We just say this is be lazy something and only evaluate it if we have to, because we had that problem with get build fields, context get build fields, because it would encode the entire chain, which would be slow. So
Yeah, that's good.
now we lazify it a bit.
Yeah,
I didn't
that's
really
very
test it, but I think it should be faster.
Yeah, I also did a lot of
Yeah.
lazification inside of the resolution algorithm.
Yeah.
I also have a lot of problems with the monos, with the monomorphs,
Oh,
because if you unify a type with another type and the
Right.
type has monos inside of it, then they get unified, and it's hard to deal with it. So I actually do the stuff that you do in the compiler with the duplicate type stuff.
yeah.
This is
So
something that I exposed to the macro API
Oh, okay,
actually,
yeah.
because it's possible inside of and there's also this is also the place where I had this problem with the ref stuff of the monos when you have the round trip.
Mm.
Yeah, maybe you know what I mean. It
Yeah,
was
you
this.
can't encode monos.
You can encode them.
Yeah.
Yes, and
You can, but it's not pretty.
yeah, that's it. Actually, I have some more examples, but I don't know if you
Alright.
can
Thank you.
get more.
Any questions from the stream chat, or did they all
No,
fall asleep?
they all
Okay.
just like